In this video, we'll explore measurement scales. Our objectives are to distinguish between nominal, ordinal, interval, ratio, and absolute measurement scales, as well as identify the measurement level of data given some background information. Measurements are not the same as the attribute or characteristic studied. If we wish to draw conclusions about an attribute or characteristic, we must first consider how the measurements correspond or map to the attribute or characteristic that we are studying. The relationship between assigned numbers or symbols and the corresponding underlying property, characteristic, or attribute yield a certain level of measurement. This is often referred to as a measurement scale. The measurement scales included are nominal, ordinal, interval, ratio, and absolute, which is considered by some as a class of ordinal data. And under certain conditions, we can consider it ratio discrete, meaning it has some properties similar to ratio, and the techniques used for ratio data can be used with the absolute data. First, we'll look at the nominal scale. The nominal scale is a scale in which numbers are assigned in order to categorize, identify, or name attributes. Examples of the nominal scale include zip codes for a certain area in the United States in which someone might live, phone number area codes, numbers assigned to types of nonconformity in products, numbers assigned to the presence or absence of an attribute, and numbers assigned to sales territories. The nominal scale is considered qualitative, things we count. The main statistic calculated for the nominal scale is the mode or category with the highest frequency of occurrence. Statistical analysis, of course, is restricted to the frequency or proportion of values in those assigned categories. So nominal scale values can only be used to indicate equal or not equal. Here's an example of the use of the nominal scale. We have a frequency table here and a frequency histogram. You'll see here that there is a code or number assigned to each of the categories of marital status from this data from 2018. Note that code 1 corresponds with married, 2 widowed, 3 divorced, 4 separated, 5 never married, and 9 is no answer. We can count the number of responses in each of these categories, and also, with respect to how many responses we got, calculate a relative frequency to look at the proportions in each category. Looking at the frequency histogram, I can see here that the most frequently occurring category is category number 1, or number 1 on the scale, which corresponds with those who indicated they were married. And then the second highest would be never married, third divorced, and so on. Next, we have the ordinal scale. In the ordinal scale, this implies order. Numbers are assigned to observations such that the order of the numbers correspond to the order of the underlying property or characteristic being studied. Examples of the ordinal scale might include a 5-point scale to measure customer satisfaction, letter grades for academic performance, sound intensity measured in decibels, socioeconomic status, or project priority numbers. Ratings and rankings are always ordinal. With ratings, we assign a subjective score to scale. This is something you may have seen in a survey. Rankings result from sorting items and assigning a unique number to each item. Now, rankings always have a greater resolution than ratings, therefore they're preferred, but there's usually more effort required in order to get a ranking. With ordinal data, or ordinal scale data, any order-preserving transformation can be used. An indicator of the center of the data would be the median or the mode, and for dispersion or spread of the data, we look at the range or interquartile range. Ordinal scale values can be used to determine equal, not equal, greater than or less than as well, but we can't determine the magnitude. And here's why. Measurements with ordinal scales are ordered in the sense that the order of the measurement scale reflects the order of the underlying property. However, it's important to note that the intervals between the numbers are not necessarily equal. For example, on the measurement scale, a difference between a 4 and a 5, although it seems equivalent, or a 3 and a 4 seems equivalent, does not represent the same size or even proportional difference in the underlying property as a scale difference between 0.3 and 0.4. We can only say it's more or less, but we can't say by how much. And again, order-preserving transformations can be used. The median mode describe the center of the data and the range or interquartile range, which we'll learn about in subsequent videos. There are many non-parametric hypotheses tests that are available for data that are ordinal. It often involves ranking the data prior to conducting the inferential statistical analysis of interest.